Hello, class 12th physics, electromagnetic waves. I have discussed about electromagnetic wave spectrum in a separate video. I will put its link in the description. So here, what is an electromagnetic wave? So I'm going to start by explaining about its origin. So first we will discuss about origin of EMW. So the origin of electromagnetic wave, an accelerated charge, or we can also say oscillating charge. That is actually much easier to explain electromagnetic wave. Oscillating charge releases its excess energy in the form of electric and magnetic oscillating fields, which are perpendicular to each other and perpendicular to the direction of propagation of wave. In fact, the answer can be this much only: an accelerated charge releases its energy in the form of electromagnetic wave. Such wave is called electromagnetic wave. So how so this wave is a transverse wave, and how does it look like? So for that, we can give its mathematical equation for that. So there are certain conditions. So if wave is propagating along positive x-axis, its electric field vibrations is in y direction, and its magnetic field vibrations is in z direction. Then okay, first I want to draw this. So its 3D diagram will look like this. This is the direction of propagation along x-axis. This is y-axis, in which electric field vibrations are there in positive as well as in negative. This is the electric field, its amplitude E naught or peak value. And along z direction we have magnetic field. So magnetic field, show it with smaller amplitude. So its amplitude is B naught. So it is giving its value, electric field's value, and here it is magnetic field value. So according to this this condition, this situation in which wave is propagating along x-axis, its electric field is along y and magnetic field is along z-axis. So its equation will be, it will have equation of electric field. I am putting a subscript y so that we could easily understand that its vibrations are along y-axis, is equal to E naught. See, a general equation, a general sinusoidal equation is y equal to a sine omega t minus kx. If it is propagating along positive axis, then here negative sign occurs and here x. So E naught sine omega t minus kx. And in the same way, magnetic field, which is along z direction, is equal to b0 sine omega t minus kx. This phase term is same, angular term is same for both. That is why they are rising and falling in same phase. However, their amplitudes are different, and this E naught upon B naught is equal to C. And this omega is called angular frequency, which is 2 pi nu or 2 pi by t. This k is called propagation constant, is equal to 2 pi by lambda. And this omega upon k is also equal to c. And this new lambda is also equal to c. And one more thing, this c is also equal to 1 upon root mu naught epsilon naught, where mu naught is permeability of free space related to magnetism, and epsilon naught is permittivity of free space related to electricity, I mean electrostatics. But these equation can have any of the following form. It can be E naught sine kx minus omega t, and all of these are moving along x-axis, positive x-axis. It can be, I'm not saying that this is equal to this, it can be in this form also. It can be in the form E naught cos omega t minus kx, and it can be in the form E naught cos, it is looking like plus, actually there is minus, cos kx minus omega t. In any of this form, this equation can be asked in the exam, so not to get confused, just remember one thing: if there is negative sign in between kx and omega t, then it means it is moving along positive x-axis. And in the same way, I'm not writing it for magnetic field, you can understand it of your own. Now let us suppose it is moving along, wave is propagating along negative x-axis, and same electric field is along y-axis and magnetic field is along z-axis, then it will look like this. It is going toward negative x-axis, nothing will change. As you can see here, that's all. So what will be the change here? So Ey equal to E naught sine omega t plus kx, or it can be Ey equal to E naught, not with this graph will somewhat change, but it is also available. So this is also, don't correlate it with this graph, for these graph will change. So also E naught also available, sine, oh this time it is I don't think it is required to move them, commute them. So I'm writing it for cos omega t plus kx. So just remember one thing. Here you will have electric field or magnetic field term, then equality sign, then peak value of electric field or peak value of magnetic field. And then either you can have cos term or you can have sine term, sine or cos. And then either you can have omega t minus kx or kx minus omega t if moving along positive x-axis, and omega t plus kx, no need to do vice versa, if moving along negative x-axis. So keep these things in your mind. This is all about its equation. So this is physics bugs left hand rule for electromagnetic wave, and you will find this rule nowhere else. So this is exclusively mine. And why we are using this? Because there can be some confusion between this electric field, magnetic field, and direction of propagation. So here it is. I'm drawing it. So according to this rule, you would say it is looking like Fleming's rule, yeah, but I'm not talking about magnetism and current. So if two things we know, we can find the direction of third. So if in an electric field, in an electromagnetic wave, thumb is pointing toward the direction of electric field vector, first finger is pointing toward direction of propagation, then middle finger will show the direction of magnetic field. So in fact it is true when electric field is in downward direction and magnetic field is in inward direction. You can see electric field upward, magnetic field along this. So direction of propagation is along this direction. So then wave will change its peak, and at that time still it is going in this direction. So either it is going up or it is going down, up and down. Direction of wave is along this direction only. So if we have electromagnetic wave propagating along positive z direction, so in this case electric field will be along y axis. Or I'm not telling it certainly. I'm saying that if electric field is along y axis, then certainly magnetic field will be along plus x axis. So two things, we have to be certain for two things, and then we can certainly assign the direction to third thing. So this is the direction of propagation if, and this is the direction of electric field vectors, then this will be the direction of magnetic field. So how can we say that this is the direction of electric field? So it will go like this. So if, see, imagine this is a surface, so it will go like this. Electric field vector will come this way and that way also, but wave will propagate along this direction. So this will be the graph. It is a 3D graph. You need to be very imaginative about it. It is x-axis. So here I'm drawing this as E naught. It's showing that I have shown electric field along this direction and magnetic field along this direction. So it will look like this. And in the same way, if it is, so what will be the equation? So E along, oh, well, I have taken this as z direction, but generally it is taken as y direction. So I'm changing it. I'm calling it y, and electric field is along z direction. So Ez is equal to E0 sine omega t minus ky, and Bz equal to B0 sine omega t minus ky, and so on and so forth. In the same way, if wave is propagating along z direction, this time instead of positive I am taking negative z direction. This is positive z direction, so that will be the negative z direction. So wave is propagating along negative z direction. So here it is. So, and if electric field is along y direction, then magnetic field will be along x direction. So in this case wave will look like this. It is showing electric field, and this will show magnetic field. So what will be the equation? So for electric field, this time electric field vibration along y-axis equal to E naught sine omega t and plus k z. And in the same way, bx actually, b, oh, pardon here, actually b is along x-axis. All right, so bx equal to b naught sine omega t plus kz. So this is how we have to deal with these directions given in the question and the equations related to them. So here is the summary of properties of electromagnetic wave. These are transverse wave. Electromagnetic wave travel through vacuum with speed c, that is 3 into 10 to the power 8, and we know that this c is 1 upon root mu naught epsilon naught. It can be nu lambda, it can be omega by k, and which is equal to E naught by V naught. So clearly for some other medium, C will change to V, and so also that will mu and epsilon will be there for that medium. Nu will remain same, wavelength will change, and so other terms will also, omega will remain same but k will change, k for medium, but so okay, next, electromagnetic wave carry oscillating electric and magnetic field. Electric and magnetic field in electromagnetic wave are in same phase. Same phase, that is why their equation, as I told you earlier, if this has the term sine omega t minus kx, it is also containing same term. If it is containing omega t minus kx, then we will also contain the reverse term, and like here. So this is phase term, angular part we can say. Next, electromagnetic wave carries momentum given by P equal to h by lambda, according to de Broglie hypothesis. P equal to mc. This m is actually their moving mass. Their rest mass is 0. This is also an important point. I haven't mentioned it here, but it is also required. So I'm putting it as an important point, that its rest mass of EMW is 0, but its moving mass is something, equivalent mass multiplied by its velocity. And it is also momentum also given by u by c. U is its energy. Due to their momentum, they can knock out electrons when incident on that object. Electromagnetic wave carries energy given by E or U. Actually, U is preferred, equal to h nu, which is hc by lambda. Also mc square. Once again, their moving mass, not the rest mass. Electric energy density of electric field in an electromagnetic wave is ue 1 by 2 epsilon naught e square. E at that instant, what is the value of electric field there, and in the same way for magnetic field, and both energy densities are same in electromagnetic wave. Electromagnetic wave do not get deflected by the presence of external electric or magnetic field. They are pulsating, fluctuating electric and magnetic field, but it is not deviated by external electric or magnetic field. They do not required medium to travel. So that is why electromagnetic wave can travel through vacuum also. When medium changes, their wavelength and hence speed changes, but not the frequency. This is explained in detail in optics chapter. Here, one more thing I want to tell you before concluding this entire lecture is that these waves, once again I'm writing them here, RAM IVUXG. So you can see most fatal wave is gamma. So most fatal, least fatal. They are also, radio waves are also dangerous to us. RA stand for radio, micro, infrared, visible, ultraviolet, X-ray, gamma rays. I have told you about it in another video. I will put its link in the description. So most fatal, why it is most fatal? Because it carries high energy. Its energy is high, and relatively radio waves energy is low, and we know that E equal to h nu. So its frequency is high, so its frequency is low, and we know that E equal to hc by lambda also. So lambda is in inverse proportion, so its wavelength is low, so its wavelength is high. And by understanding this, we can easily say that we can easily arrange these waves in terms of increasing or decreasing frequency or wavelength. So such type of question asked in the exam, we can now easily arrange them. So we can write that frequency of gamma is greater than frequency of X-ray, is greater than frequency of ultraviolet, is greater than frequency of visible. And in the visible section there are Vibgyor, and we know about their frequency also. So we can also do it like this: frequency of violet is greater than frequency of indigo, and so on, and frequency of red. Now frequency of infrared is greater than frequency of microwave, is greater than frequency of radio wave. And conversely, wavelength of gamma is less than wavelength of X-ray, is less than wavelength of ultraviolet, is less than wavelength of visible. And in the visible region, wavelength of violet is less than wavelength of red. Rest of the terms will come here. So it is less than wavelength of infrared, less than wavelength of microwave, is less than wavelength of radio wave. So that's all. Bye bye.